The prototype sat on the inspection table in Turula, Finland, in the spring of 1960. It looked familiar to anyone who had seen Soviet equipment: the curved magazine, the wooden furniture, the general profile of a Kalashnikov pattern platform. But this wasn't a copy. The engineers at Valmet, Finland's state-owned manufacturer, had been given a mandate that seemed straightforward on paper: develop a modern service rifle for the Finnish defense forces. In practice, that mandate carried implications that extended far beyond simply choosing a design and putting it into production. Finland's position demanded careful consideration. The country maintained official neutrality, but its recent history spoke of hard-won independence and the necessity of self-reliance. Past conflicts had demonstrated both the capability and determination of Finnish defenders, but they had also revealed the vulnerabilities of depending on foreign suppliers during a crisis. Now, in the early 1960s, as global tensions structured international politics, Finland needed to ensure its forces could be equipped domestically. The question wasn't whether to produce an indigenous tool, but what form that tool should take. The Valmet engineers began with thorough analysis. The Soviet AK-47 had proven itself effective in large-scale production and field service. Its gas-operated rotating bolt mechanism was robust and relatively simple to manufacture. More importantly, it functioned in conditions similar to those Finnish personnel would encounter, rather than attempting to engineer an entirely novel system. The Valmet team decided to use the Kalashnikov mechanism as a foundation while addressing specific Finnish requirements through careful modification. The early prototypes revealed challenges immediately. Finland's manufacturing infrastructure differed from Soviet facilities. The quality standards expected of Finnish equipment exceeded typical tolerances. And most critically, Finnish operating environments presented extremes that would test any mechanism. The first test units performed adequately in temperate conditions, but Valmet's engineers knew that adequate performance in spring weather meant nothing. The true test would come when temperatures dropped to -30 degrees Celsius and operators worked in darkness, wearing heavy gloves with equipment covered in snow and ice. The project moved forward with characteristic Finnish precision. Each component was evaluated not just for functionality, but for reliability under worst-case conditions. The receiver design underwent multiple revisions. The sight system was reconsidered. The furniture materials were tested against temperature extremes. This wasn't rapid prototyping aimed at getting something functional into production quickly. This was methodical engineering, acknowledging that lives would eventually depend on decisions made in Turula workshops during those early years of development. If stories like this help you see how engineering quietly shaped history, tell us in the comments what surprised you so far, and stay with us for the next chapter. The engineering team at Valmet operated under pressures that weren't immediately visible in the technical specifications. Risto Hietiainen led the design group, and he understood that every choice carried implications beyond mechanical function. Finland had emerged from the mid-century global conflict maintaining independence, but at significant cost. Post-conflict treaties had imposed limitations on Finnish equipment, though by the early 1960s those restrictions had eased. Still, the memory of constraint influenced planning. Any system adopted would serve for decades, and choosing poorly would mean either expensive replacement or prolonged obsolescence. The Soviet Union had offered to supply AK-47 units, which would have solved the immediate need while ensuring ammunition compatibility with potential neighbors. But accepting that offer meant accepting dependency. If political circumstances changed, supply could be interrupted. Maintenance documentation, spare parts, manufacturing knowledge, all would remain outside Finnish control. The Valmet project represented not just equipment development, but industrial strategy. Hietiainen's team faced practical constraints. The Valmet facility in Turula produced civilian hunting and target tools, not military hardware in quantity. Transitioning to large-scale production would require investment in tooling, training, and quality systems. The receiver design presented the first major decision. Soviet AK-47s used stamped sheet metal receivers, which enabled rapid production but required specialized presses and techniques. The AKM, introduced in 1959, refined this approach further. However, Valmet's existing machinery was suited to machining operations, not large-scale stamping. After analysis, the team chose to machine receivers from solid steel forgings. This decision increased production time and material costs, but it matched available capabilities while producing components of exceptional strength and consistency. The machined receiver wouldn't dent or deform under impact the way stamped metal could. Finish quality standards demanded this level of durability, even if it meant slower production rates. The barrel manufacturing process received similar attention. Finnish barrel makers understood precision. The nation's hunting tools had earned international respect for accuracy. Applying that expertise to the new project meant RK-62 barrels would be held to tighter tolerances than typical standards required. The rifling process used button rifling rather than cut rifling, producing smoother bore surfaces that enhanced accuracy and reduced fouling. By late 1961, the prototypes had evolved significantly from the initial designs. The tool retained the fundamental operating system, but nearly every component showed Finnish engineering influence. The rear sight was redesigned with a different elevation mechanism. The gas system components were manufactured to tighter specifications. The wooden furniture used Finnish birch, selected for its density and resistance to moisture. These weren't dramatic innovations, but each represented careful engineering judgment about what Finnish personnel would need. The first comprehensive trials began in January 1962, deliberately timed to coincide with Finland's harshest winter conditions. Test units were distributed to squads stationed north of the Arctic Circle, where January temperatures routinely dropped below -30 degrees Celsius. The testing protocol was straightforward. Use the tools under normal operational conditions, document any malfunctions, and report on reliability, accuracy, and handling characteristics. Early reports revealed issues immediately. Several units experienced trigger problems in extreme cold. The original trigger return spring, though adequate in laboratory testing, weakened at low temperatures, occasionally failing to reset the mechanism properly. The engineers had anticipated that metal components would contract in cold, but the interaction between contraction and spring tension proved more complex than predicted. A redesigned trigger spring with different steel composition and heat treatment solved the problem within weeks. The wooden furniture presented another challenge. Despite using dense Finnish birch, some stocks developed cracks after repeated freeze-thaw cycles. Arctic field conditions involved dramatic temperature swings. Equipment stored outside in -30-degree darkness might be brought into heated tents, exposing the wood to thermal shock. The Valmet team experimented with different finishing treatments and moisture barriers. Eventually, they developed a laminated wood structure with improved dimensional stability. This wasn't simply applying more varnish. It required reformulating the adhesives to maintain bond strength across temperature extremes. Accuracy testing produced encouraging results. The RK-62 consistently grouped better than official specifications required at 300 meters. The machined receiver's rigidity contributed to this precision, as did the high-quality barrel manufacturing. Finnish doctrine emphasized accurate semi-automatic engagement, and the tool delivered the mechanical precision that doctrine required. Operators reported that the tool felt stable during aimed use, with recoil characteristics that allowed rapid follow-up shots while maintaining target alignment. The reliability data exceeded expectations. After thousands of rounds discharged in Arctic conditions with minimal cleaning and no special maintenance, the RK-62 prototypes demonstrated functional reliability comparable to the AK-47 while maintaining tighter manufacturing tolerances. This validated the Valmet team's core assumption that increased precision in components didn't have to compromise reliability if clearances and tolerances were properly engineered. One unexpected finding emerged during night operations. The tool's balance point and handling characteristics proved particularly well suited to operation with heavy winter gear. The slightly forward weight bias, a consequence of the machined receiver and solid wooden furniture, gave the tool stable handling even when operators wore thick gloves that reduced tactile feedback. This wasn't something that had been specifically engineered, but it demonstrated how integrated design decisions could produce benefits beyond their primary purposes. By spring 1962, the Finnish Defence Forces had sufficient data to make their adoption decision. The tool worked. It worked in conditions that challenged most hardware, it could be manufactured domestically with Finnish industry, and it provided the accuracy and reliability Finnish doctrine demanded. The element that most clearly distinguished the RK-62 from its Soviet predecessor became apparent when users compared trigger characteristics. The Kalashnikov trigger mechanism is functional but not refined. It incorporates the minimum complexity necessary to provide safe operation. The trigger pull is heavy and somewhat gritty, acceptable for suppressive use, but not ideal for precision. Finnish engineers completely redesigned the fire control group. This wasn't merely smoothing surfaces or lightening springs. It was a geometric redesign of how the trigger, hammer, and disconnector interact. The hammer pivots on a crosspin, as in the AK-47, but the trigger itself engages the hammer through a different surface geometry. The disconnector mechanism, which manages the semi-automatic cycle, was reconfigured to minimize interference with trigger pull quality. The result was quantifiable. Trigger pull weight decreased from the AK-47's typical 7 to 8 pounds down to approximately 5 pounds, with significantly reduced creep and a cleaner break. For context, specialized target tools might have 2 or 3 pound triggers, but standard equipment requires heavier pulls to prevent accidental discharge under field conditions. The RK-62's 5-pound trigger struck a deliberate balance. Heavy enough for safety with gloved hands and under stress, light enough for accurate aimed use. This improvement reflected Finnish tactical philosophy. While some doctrines emphasized volume of fire, Finnish doctrine, shaped by different operational contexts, valued precision. Finnish personnel trained to make every shot count, engaging targets at ranges where controlled use delivered better results than automatic spray. The improved trigger made that doctrine practically achievable. The engineering required to accomplish this trigger refinement shouldn't be underestimated. The fire control group occupies limited space within the receiver, and every component must function reliably after exposure to moisture, sand, ice, and mud. Reducing trigger pull weight while maintaining reliability meant precise attention to surface finish, spring rates, and engagement angles. The disconnector had to release cleanly without catching or dragging. The hammer had to fall with sufficient force to reliably initiate the cycle, even if spring tension varied due to temperature. These requirements don't allow for simple solutions. Testing the trigger mechanism involved both measurement and practical evaluation. Engineers used specialized equipment to measure pull weight, creep, and over-travel precisely. But the real validation came from personnel using the tool under field conditions, reporting on whether the trigger behavior supported accurate placement. Multiple iterations refined the geometry until the mechanism delivered the desired characteristics reliably across the full range of environmental conditions. This focus on the trigger mechanism reveals the RK-62's underlying design philosophy: Identify what your specific tactical doctrine requires, then engineer those elements to perform optimally within the constraints of reliable service. The result wasn't the lightest or smoothest trigger in absolute terms. It was the best trigger that could be reliably manufactured and maintained within the RK62's operational context. The Valmet RK62 entered Finnish service officially in 1962 and would remain the standard service tool for over 4 decades. This longevity wasn't accidental. It reflected the fundamental soundness of the engineering decisions made during development. The tool served through the remainder of the Cold War, through the dissolution of the Soviet Union and into the 21st century, proving adaptable to evolving tactical requirements while maintaining its core reliability. Production at Turulla continued through several variants. The RK62M incorporated minor improvements based on service feedback. Later versions adapted the design to 5.56 645 mm NATO ammunition as doctrine evolved internationally. Valmet also produced export versions, with the tool earning respect in international markets where users valued its combination of rugged reliability and manufacturing quality. Finnish reserve forces operated the RK62 alongside regular units, demonstrating its versatility across different organizational contexts. The tool's reputation extended beyond Finnish borders. Observers noted that the RK62 consistently outperformed most Kalashnikov variants in accuracy while matching them in reliability. This combination of attributes seemed to violate conventional wisdom that reliability and precision were competing values in design. The Valmet engineers had demonstrated that with sufficient attention to manufacturing quality and tolerance engineering, both objectives could be achieved simultaneously. The tool's service record validated every decision made during development. Reports of malfunctions or failures in the field remained extremely rare. When maintained according to standard protocols, the RK62 proved capable of discharging tens of thousands of rounds with minimal parts replacement. The machined receiver, though more expensive to produce than stamped alternatives, never cracked or failed structurally. The barrel's high-quality rifling maintained accuracy even after extended use. The trigger mechanism continued functioning smoothly across decades of service. Perhaps most significantly, the RK62 established Finland's capability to design and manufacture advanced equipment domestically. This wasn't just about having tools, it was about maintaining industrial knowledge, engineering expertise, and manufacturing infrastructure that could support national defense independently. When Valmet later developed other systems, they built on experience gained through the RK62 project. The tool's design also influenced subsequent Finnish equipment development. The emphasis on Arctic reliability, the preference for robust over lightweight construction, the focus on accuracy within acceptable weight parameters. These priorities established during the RK62 program shaped Finnish engineering culture. Later projects reflected a similar engineering philosophy. As Finnish forces eventually transitioned to more modern designs in the 2000s, the RK62 didn't disappear. Many remained in reserve stocks, still perfectly functional after decades of service. Some found civilian applications as sporting tools. Others were transferred to allies or retained for specialized roles. The tool's operational lifespan exceeded 50 years, a testament to design decisions that prioritized lasting value over immediate cost minimization. The Valmet RK62 ultimately represents engineering at its most pragmatic, understanding requirements clearly, choosing appropriate solutions, and executing with precision. It didn't revolutionize tool design. It didn't introduce radical innovations. It simply worked reliably in the conditions where it was needed most, manufactured by Finnish industry according to Finnish standards. That achievement, though quiet, proved more valuable than any dramatic innovation could have been. If you enjoy calm, true stories about how engineering shaped the world, subscribe to the channel, leave a like, and tell us from which country you're watching. Would you like me to translate another script, or perhaps focus on a specific technical era of Finnish engineering?